Hello P6, it's time for us to think about Wednesday's maths lesson. Now, for our warm-up today, we're going to get underway with an ultimate times table challenge. I want you to set a timer for 15 minutes, so get a mobile phone or a tablet, something where you can set a timer for 15 minutes. And then what I want you to do is see how many of these questions you can answer in 15 minutes. Some of you might be able to answer every single one of them. Some of you, well, you might find it a little bit harder, and that's okay. But what I want you to do today is try within 15 minutes to answer as many questions on this page as you can. It's all your multiplication tables, but they are jumbled up. So do your best. Whenever you get finished, jot down how long it has taken you. So if you manage to finish it, say, in 11 minutes and 2 seconds, then write that at the top of your page. But if it took you 15 minutes, that's okay. If after 15 minutes you haven't finished, just stop, okay? You don't need to keep going after that, but do your best for 15 minutes to fill in as many as you can. Remember, if you find your times tables hard, why don't you download the multiplication tables fact sheet and keep practicing those at home. So that's your warm-up for today. Do as much of it as you can. And then we're going to continue with the work that we've been doing, looking at area. We've already talked so far this week about these two words, area and perimeter. Remember that area, we're looking at the amount of surface that is covered by a shape. And we measure that surface in squares. So we're looking at the individual squares that make up each of these shapes. And often these squares are centimetre squares because they're 1 centimetre across and 1 centimetre down. So they're normally centimetre squares. They don't have to be centimetre squares. They could be bigger than a centimetre, smaller than a centimetre, and that's absolutely fine. But if they're centimetre squares, we'll write down that they're centimetre squares. Now, over the last 2 days, we've been practicing looking at area. And what we've been looking at is looking at the area of squares and rectangles. And yesterday, what we were thinking about was if we know the length and the breadth of a rectangle or a square, we have been thinking about multiplying the length times breadth to work out the area. But of course, not every shape out there is a square or a rectangle. There are lots of other shapes out there, and we need to be able to work out their area as well. So take a look at the shapes that I have here on this page. Each square is 1 centimetre squared. What is the area of each shape? Well, if I look closely at any of these shapes, I can see that inside each of them, there are lots of full squares. So if I was to look at this yellow shape, I can see that there are lots of full squares, but it's not going to be as easy to work out the area as just to count across, count down and multiply the two numbers together, because there are some squares within the outside rectangle. If I drew a rectangle around it, there's some squares that aren't part of my shape. So how do I find the area of a shape like these? Well, what I do is I start off by counting the full squares. So I'm going to take my pen, I'm going to write in all of the full squares. So I'm going to write numbers in each and every one of my full squares. And I want to see how many full squares I have got all together. So how many full squares are there in this shape? So 21, 22, 23, 24. So at the minute I can say that I have got 24 full squares. But not every square is a full square. What do you notice about this one and about this one? They're both half squares, aren't they? So in each of these, I'm going to write half. So there's a half square and a half square. Now, what do 2 half squares make? Well, if I was to take this half square and this half square and squish them together, that would be the same as 1 more full square, wouldn't it? So I've got 24 full squares and I've got 2 half squares. So if I put those 2 half squares together, that's the same as having 1 more full square. So 24 add 1, what's the final area of this shape going to be? Well, it's going to be 25 centimetres squared. Let's have a look at a different one of these shapes. So let's go for this blue one, shall we? I'll pick a better pen this time. Let's have a think about this one. So to work out the area, again, I'm going to count the number of full squares. So in the full squares, I'm going to write numbers. I want to count how many full squares I have. So I fill in my numbers. So I have got, how many full squares? I've got 18 full squares. Now I think about the half squares. So are there any half squares that you can see there? Well, there's a half, another half, another half, and another half. So I've got 1, 2, 3, 4 half squares. Now, 2 half squares together make a full square. So if I put that one and that one together, there's a full square. If I put that one and that one together, there's another full square. So I would have the same as 18 full squares plus another 2 made up of half squares. So what's my final area for that shape going to be? Yep, it's going to be 20 centimetres squared. So if I have a shape where it's made up of full squares and some half squares, then I work out the full squares first, write the numbers in the boxes, and then work out the half squares. Now in this one, I'm not going to count all the full squares at this point, but there's 3 half squares. So I could put those 2 together and there would be another half there. So that would be the same as 1.5 plus all the full squares. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So I've got 24 full squares plus 1.5. What's that going to equal altogether? Well, 24 add 1 is 25. 25.5 centimetres squared. So if you have a shape that's made up of full squares and half squares, we write the numbers into the full squares, we write half in the half squares, and then we put our halves into groups of 2. But that doesn't work for every shape. What about these ones? These are what we call irregular shapes. And they're irregular because, well, there are full squares, but the bits that aren't full squares might be half, but they might be more than a half or less than a half. Let's take this one. I wonder if we could work out the approximate area. We're not going to be able to work out the very exact area, but we're going to work out an approximate area. Now, with shapes like this, what I have to do is count the full squares and all those that are at least half a square. I'm going to start off with the full squares. So I'm looking for any square where the whole square is there, and I can definitely see all of it. Nothing is missing from that square. There's no corners that have been cut off or anything like that. So in this shape, I've got 12 full squares. Now, what I then do is I look to see, are there any squares that are half or more? Can you see any squares that are half or more? Yep, there's one. It's not quite a full square because the corner's been cut off. In shapes like this, I keep going with my numbers. So the last number I wrote down was 12. If it's at least half a square, I keep going with my numbers. So there's 13. Yeah, I'll go for 14 because that's at least half a square. 15. 16. Is that at least half a square? Yes. So 17. Yes. 18. 19. 20. 21. 22. 23. Would you say that that square is at least half a square? Yes, I think I would. So I'm going to put 24 in there. What about this bit here? Is that at least half a square? No, I wouldn't think so. Or that little section there? No. 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 So there are a few other little bits and pieces, but They're not at least half a square, so I'm not going to write a number in each of those. So what was the last number I got to? The last number I got to was 24. So I'm going to say that the approximate area of that shape is 24 centimeters squared. It's not exactly 24 centimeters squared, but it's about that. Shall we do another one? Let's go and do this one that looks a bit like an island. So again, I start off by counting the full squares. So I'm looking for any square where none of the corners have been cut off at all. So I need to be careful as I go through it. I'm writing my numbers in as I go through it. Oh, that one's well, no, I don't think it is actually slightly cut off. What was that? 22. So 23, 24, 25. Yeah, 26. Haven't got all of that square. 27, 28. Yeah, got all of that one. So there's 29. Are there any other squares where I've got almost all of it, at least half, where I'm at 29? I'll definitely use that one. So 30. That one, yeah, I think so. 31, definitely that one. 32. I'm going to say no on that one. 33. That one, probably 34. Definitely 35. I'm going to say no. 36, 37. Maybe 38. Maybe 39. I'm going to say for that one that the area is approximately 39 centimeters squared. We can't be exact, but we're getting as close as we can. So in an irregular shape, we start off by counting the full squares and all of the ones that are at least half. We're not writing half in any of these squares. Now, for your challenge today, piece 6, you're going to choose one of two levels. So if you choose the higher level task, you're starting off with this page. Everybody's got 2 sheets to download. So first page for the higher level task. These first 2 shapes are made up of full squares and half squares. So write the numbers in the full squares, write half in the half squares, and work out what the overall area is. Then your 3rd, 4th, 5th and 6th questions, you're going to find an approximate area. The area will be about something. So think what we were just doing. Write the numbers in the full squares and then keep going with your numbers in the ones that are at least half or more. Once you've done that, if you've chosen to do the higher level activity, then I want you to think a bit more about these irregular shapes. Can you work out the size approximately of these 2 footprints? Then make your own animal footprints. Draw some animal footprints in these sections, and can you work out the approximate area of those? And if at home you happen to have any centimetre squared paper, could you draw around your own foot and work out the approximate area of your foot? If you choose to do the lower level activity, you have got some different shapes where you need to count the full squares and the half squares and work out their area, and a chance to draw your own picture to go with it. And if you choose to do the lower level activity, then your second challenge is with these shapes on the nature trail, you're going to try and find the approximate area. The area is about whatever. Now, on the website, all the details are there. I've reminded you about what we've just done in today's lesson. P6, once you've had a go at your area work, why don't you go and have a go at today's logic problem, where you need to do a little bit of working out. And then why don't you finish off today by playing Prodigy. Amazing scores so far this week. Keep up the good work. We're very proud of every one of you.